Welcome to our project presentation for course CS6604, Advanced Topics in Data and Information. In this demo, I'm gonna introduce the application we developed for the course project, Bikeshare System Prediction and Route Recommendation. This application uses spatial data mining methods with database management and data visualization techniques to facilitate the trip planning for capital Bikeshare users. So let's take a look at the user interface of our application. There are two important components. One is the map panel, which covers most of the web page space, and the other is the search menu. And the map shows the locations of the capital Bikeshare stations across the District of Columbia. It's pretty easy to move around, zoom out, and zoom in. So each marker on the map is one of the Bikeshare stations, and the color combination can tell us the different station status in real time. The light blue color represents the availability of docks at each station, and the orange color tells us the bike availability. If there's a high ratio of orange color on the icon, then we know like the majority of the bikes at that station are available around that time. We can get a better idea by randomly checking on several stations. For example, if we click on this station, an information box will pop out with the information shows the station name, ID, the last time the system was refreshed, and most importantly, the number of bikes and docks available. We observe that there's no bikes available at the station, so it's fully light blue color. And we can check another station, and for this station, few bikes have been checked out, and only 3 docks are available at this station. And we can check on a third case at 10th Street and Constitution Avenue Northwest station. It has 15 bikes available and 10 docks available. So the station is pretty balanced. We can close that. When examining the real-time Bikeshare station status in the district, we can notice that the Bikeshare usage in different areas of the city are highly imbalanced. For example, now for the stations in downtown area, there are a lot of bikes available. But in the Cardozo neighborhood in DC, the majority of the bikes have been checked out, and the stations are pretty empty. So just think about this scenario. For Bikeshare users who rely on capital Bikeshare for daily commuting during peak hours of a day when they arrive at the station and want to check out a bike to commute to work, but there is no bike at the station available, and he need to search around other stations for available bike, which is really inconvenient. And our application is trying to deal with this issue for more convenient bike trip planning. Now let's take a look at the second component of our user interface design, the search menu. If we click on the menu button, a set bar will come up on the left with several input boxes. As we notice here, the current time will be automatically recorded in the first box. And or you can set a time in the future when you plan to start your trip. And the trip start and the destination points can be easily set by a few clicks on the map, which I will show you later. After all the information inserted into the boxes, with a simple click on the search button, the application will recommend the best routes for Bikeshare users. So we also take the cyclist safety into consideration in our project. So here we have a button to show the locations of bicycle involved accidents in the district. Just click on it, and the red dots represent where the bike accident happened in the past. And just by click it one time, and it will disappear. To provide you with a better understanding about how it works, I will present a case study of planning a Bikeshare trip using our application. So we can zoom in a little bit and say if we want to start a trip from Capitol Hill, and we can just right click it and set it as a start point, and the latitude and longitude of that location will be automatically inserted into the input box. And say we want to go to downtown area, and just by right click on it and set it as destination point, and just simply click on the search button. After a little time of thinking, the system will recommend a list of routes for us. So the route rankings are generated by a mixed ranking method, which takes consideration of trip duration, the number of available bikes and dogs, and cyclist safety into consideration. So we can check each route by clicking on each of them. So here is the first one, here is the second, here is the third. So we have top 10 best routes recommended by our application. And so you had the idea, and we can take a closer look at the first recommended route here. And see, A is our start point, and B is our destination point. And the our application recommends the user to check out bike from the Eastern Market station. And interestingly, it did not recommend the user to check bikes from the closest station because the system predicts there would be no bikes available at that time. So the application recommends users to go to Eastern Market location. And for the destination, the users are recommended to return their bikes to the 17th and the K Street Northwest. So which have 4 docks available. So it's highly possible that the user, when the user arrive at that station, the station have available docks for users to return the bike. We can see here planning a bikeshare trip with our application. Users can avoid to be directed to the stations with no bike or no dock available. And with the Bikeshare crash data visualization, users can be more cautious about their cycling on the planned route. So another feature of our application is that it can help a user to plan the trip early. So, for example, if a Bikeshare user plans to take a trip half an hour later, and all he or she need to do is to change the time in the input box, and our application will recalculate the recommended routes to them based on the prediction of the Bikeshare station status at that time. Users can scroll down the left bar to have an idea of the time duration, distance, the start station name and the destination station, and the number of bikes and docks available for each station, and also the bike accidents on the streets. And by thinking about the different trade-offs, users can select the best route for cycling. So to sum up, the unique features of the application we developed include that the first is the flexibility in choosing start time and the start and the destination points to plan for a trip for the current time or for a time period after. And the second is the route recommendation based on bike demand prediction, which can help users to avoid the Bikeshare stations which has no bike or dock available upon their arrival time. So, and we also take the cyclist safety into the route recommendation as well. And lastly, the user interface provides users with a variety ways to interact with the application for trip plannings. That's pretty much it for our course project. Thanks for watching.